Okay, let us proceed. Until now in this session, we had a look at the basic data types, but all the program controlling the flow of the program was always linear. So if you look at the worksheet which we have so far, you see that basically here we were just executing the cells each after. But basically, we could, if we wanted to go back and repeat something, then we had to navigate there with the cursor arrows. And of course, if we have to deal with real problems and write real programs, then we have to modify somehow the code flow, and especially we would like to have constructs where we can decide whether a certain part of the code is executed or not, and we would like to have some ways in order to jump around in the code, so to return to a given point and start the execution again from a given point. And this brings us to the code flow structure comments, and this is exactly what we will have. We will deal in the second part of this session now. The first one is the so-called branching. You know it hopefully also from other programming languages, the so-called if branch. So basically we are evaluating a condition, and if this condition is true, then we are executing a given code. If not, we are proceeding and we are skipping that part of code, and we can combine it with further tests. And again, if that's a further test, like a condition 2 is true, it's evaluated to true, then we will here execute the second code block, and so on and so on. So basically you can make a nested if with many conditions, and you can have an else at the end which is executed if none of the blocks here has been executed. And then basically it doesn't matter whichever of those blocks is executed, the program, only one of those is executed, and the program basically finishes or starts after that certain block, the selected block, has been executed. The program continues after the entire block. Okay. How do you, in Python, there is a very important thing, how you can mark blocks. And blocks which belongs to a certain part of an if statements are marked by indentation. So in contrast to other programming language where you have an opening and a closing constructs for each sub-block, in Python this is the indentation, the only one which decides where a block belongs to, and therefore you must be sure that when you write a Python program you do the indentation correctly, because it has a semantical meaning. So let's have a look at this example here. Here, if you have a look, we are basically just having an answer. We will ask the user for an answer. Let's assume this answer has been stored in the variable answer. And now we are analyzing the first character. You remember here we can select the zeroed item of answer. It means that which is the first character. And if the first character is a Y, like yes, then we are printing something, and otherwise we are printing something else. And now let's type in this program in your worksheet. So let's assume answer is equal yes, just that the answer has a certain value. And now we are writing our evaluation. If the zeroed character of answer, which is basically the first one in our normal counting, is yes, then we are starting a sub-block. Sub-Python is always introduced by the colon at the line before, and you see automatically in this IPython or Jupyter notebook you have already 4 spaces as indentation. So here you can write, okay, print, what should we print? Okay, the answer was yes. Otherwise, if it's not true, what does it mean? If the first character or the zeroed character of answer was not yes, then the else block will be executed. And then here we will do 2 different commands just to demonstrate that the code can be arbitrarily long, the sub block can arbitrarily long. You don't agree, for example, this way. And then here we will just continue, print, let's continue. And if you execute that thing now, then what will happen? First of all, what will happen that we have a syntax error. Why? Because I was writing here only one as equal sign, but one equal sign in Python means assignment, and you need 2 in order to make a comparison. And now if you execute it again, it was now properly executed. It's a valid Python now, and you say the answer is yes. Why? Because the variable answer has been set to yes. So the first character is y, so this block has been executed. Once this block has been executed, the program just jumped at the end of the entire if-else construct and continued here. Now let's change the answer to something else. Let's change the answer to no and execute this and this cell. And now it's different. This condition here failed because the zeroth character of answer was not y. So therefore the else block has been executed, which was this one, which contains of 2 lines. Those 2 lines had been exactly printed as supposed, and then it continued here. Okay, so this is basically how the if branching works. Important is the indentation. There is also the possibility to write if-else construct as an expression. I won't talk much about that. Try to avoid it unless your if-else construct, it's a very, very small one, and you really can fit easily into an expression. Okay. Python is very special in a sense that basically almost everything can be evaluated after the if. As a Boolean expression. I mean, if needs something which results in a bool, in a logical value, but in Python basically everything can be interpreted as a logical value. If it's if the thing which is there, the expression, is a Boolean one, then of course it's considered to be false if the explicit value of false. But you could also pass an integer, and if the integer is 0, then the logical value is considered to be false. And if it's any other value, the logical value considered to be true. The same with floats. If it's 0.0, it's considered to be false, otherwise it's true. With complex, the same. Or for example, for strings, which we will need later, if it's the empty string, what has been entered is the empty string, then basically it's considered to be false. Otherwise, if it contains at least 1 character, it's considered to be 2. What could we do with that? For example, let's say we have a number, it should be 7. You remember if you apply the percentage operator, it gives the remainder. So basically num %2 means what would be the remainder if I divided num by the number here by 2, and this is of course the number 1. So but we can use an integer also as a bool basically. So we could write if num equal num %2, and now the question is, what would that mean? The num %2 in this case is the number 1. We said the integer number 1, basically everything which is not 0 is interpreted as true. So basically if this thing which stays here is non-zero, then it means that the number is an odd number, and otherwise the number is an even number. Why is it even? Because then num %2 is 0, but that means the if is here, this evaluates to false. Therefore the if block will not executed, will be not executed, but the else block will be executed. So let's try it, and indeed the number was 7, and here it says that it's odd. Let's try it differently. I will just delete this cell here with x. So let's change the number, let's say to 6, and execute it again, and then it would say it's even. So basically here the result of this expression, which results in an integer, is also interpreted as a decision, as a logical value. If it's non-zero, then it's evaluated, then this block is evaluated, the true block is evaluated. If it's 0, then the false block, the else block, is evaluated. Okay, so this helps you to write in Python very small and neat programs and comparisons. Okay, good. So this is one way to deal with program flow, where we are skipping one part of the code, but we can also jump back if we want to a given part. It's, so making so-called loops, so repeat something until a certain condition is fulfilled, and that's the so-called while loop. And the while loop means here I'm specifying a condition, and as long as the condition is fulfilled, the code is executed. And if the condition here up there is not fulfilled anymore, it's false, then basically the execution of the code here in the subblock will be not done anymore, and then the program flow will continue after the while block. So let's try exactly here the small program. We would like to search for all the numbers, all the powers of 2 which are smaller than 20. Let's start with 1. And then we just writing while. We will do a loop and look and do execute this loop while number is smaller than 20. And now we are making a block. And then we will just say, okay, print. We are just writing the number out, and then we will do a trick. We will say, okay, the number that should get a new value, the variable num should assign with a new value, and this new value should be the old value that the num variable num was assigned to, multiply by 2. So we are multiplying basically just the value, the value of num by 2, and storing the value again under the name num. And then here, last number, we will print the last value of num which was occurred. And now, before you execute that, try to think and imagine. Stop the video and try to think and imagine what will come out. If you did so, let's try whether what you guessed is the one which we get. So let's start it, and you see we get basically here the powers of 2 below 20. But the last number is 32. Why? We were starting with 1. Then we were doing the check. Is 1 smaller or equal than 20? Yes, of course, it's the case. Then we are printing the number 1. And then we are storing in under the name num, which means 1 times 2. So basically num no is assigned with an object which has the content 2. And then we are going back to the while loop, and then we are looking whether 2 is smaller than 20. Of course, smaller or equal, it is. Therefore, we are printing 2, and we are multiplying it by 2 and storing under the name num. And then we have 4. 4 is smaller than 20, and then 8, and then for 16. And then, okay, if num is 16, we are printing 16, and then we are basically creating 32. And assigning num to 32. And then we are jumping again to the beginning, to the while loop, and we are looking, is 32 smaller or equal than 20? And that's not the case. Therefore, this block is not executed anymore, but we are now continuing code execution after the while block. But the variable num has the value 32, and this is why here this line prints 32 as the last one. So this is basically how the while loop in Python works, and we can use it to iterate if we do not know from the beginning how often we have to iterate. So it's to typically use it for conditions where you don't know how often to make the iteration, because the iteration number depends on a condition which has to be evaluated in every loop again and again. Okay. So let's have a look. This was exactly the example which we treated now. You can, for example, use it also when you want to have a user input and you want to make sure that the user input is proper. So basically it's formatted properly. And here is a small example how you can do that. And in this example, we are using 2 different constructs, additional constructs in the while loop, and those are ways to manipulate the code flow within the while loop. You can have a break statement which would just jump out from the code, from the while loop, and continue the execution after the while loop. And we have the continue statements which would just basically jump back to the beginning of the while loop. And let's try to have this example. I will just copy paste it, but you should probably type it yourself in order to get some exercise. The problem with the copy pasting, of course, is, which is very important, that the indentation is not good, and but we know that the indentation in Python is essential. So I will just re-indent it exactly as it was in the example, and it should be here, this one. And now, again, please type this in, and before you run, try to think about what will happen, okay? And if you know, what you think would be how this code would behave. Then let's start it. And then it's asking whether we are agreeing or not. And let's say einfach some letter, something arbitrary. And then it says invalid answer. Try it again. No, okay. Then we say no, N for no, and it's a valid answer, but I don't like it. And if I say yes, then basically the program stops. Why? Let's have a look what we did here. We have a while loop. The condition to abort the while loop is true, which means it will never be aborted. I mean, true always evaluates to true. So basically this is an endless loop. It would run forever unless we are leaving the loop with a break statement from inside. So it's very important, if you have an endless loop, then you need a break statement inside. Now we have answer. We are just getting the string via the input function. We know that already. And then we are investigating whether the answer is yes or no. If the answer is not yes, and the answer is also not no, so it's neither yes nor no, then we are just printing out something. That's an invalid answer. And we are calling continue. Continue would do nothing else. That's just to jump back to the while loop and evaluate the condition at the while header. Of course, the condition is true, and then basically program execution would start it again. So basically, as long as the answer is not yes and not no, we will basically continue to repeat this this code snippet endlessly. Now let's assume the user realized that he has to type yes or no. Then we are here. And if the answer is yes, then we are printing good answer, and we are jumping out of the while loop, and then we are continuing here. This is what we have seen at the end. But if the answer is not no, so basically this if is not executed, then we are still in the while loop, and we are just printing out something which says valid answer, but it's not the answer which I expected. And then when the code execution, subcode execution here, the subcode, the sub block is at the end, then we are jumping back at the end to the header, and we are evaluating the condition again. And because the condition is true, it will be basically always fulfilled. So we are starting here again. So basically, this code snippet shows you a little bit how you can with continue and break. Either with continue, jump back directly to the header of the while loop without executing the rest of the while block, or with break, how you can leave the while block. And those two are very handy if you want to modify the program flow within a while loop. And as I said, if it's an endless loop, make sure that you are jumping out of that. The while loop can even have an else clause in Python. And this is sometimes, and it's not very often used, but sometimes quite nice. And you can use it to check whether you left the while loop without a break statement. So basically the else would be, the else clause will be only executed if you left the while loop because the condition here was evaluated to false. But if you left, for example, here the while loop via break, then the else clause will be not executed. And here in this example, it is used basically just to count the number of trials for the answer. And if the number is less than a given or exceeds a given number, then it jumps out. Okay, we can just type it in. So let's assume we are setting a variable I to 1. So this is a number of times the user already gave an answer, and we are saying we are okay, we are patient as long as the I is less than 5. So basically the number of times the user answered is less than 5. Then we will do repeat something, and if you look at here, you see that we are basically here increasing the value of I by 1. So let's do that, and then we are basically getting an answer. So let's increase I by 1, which means we are setting the value of I, or we are pointing I to a value which is the old value, which was 1 plus 1. So we have here 2, and basically I will be shown to the object 2 in the memory. We can just write it also shorter by saying increase I by 1. And then we are just getting the answer, and we are just asking for the answer. And then if this answer is not, if the answer is basically yes or no, then we are finishing. So if answer is yes or the answer is no, you see I have made a mistake again. Here I was just writing 1 equals sign, but units 2, because it should be a comparison. If the answer is correct, I mean formally correct, then we will just break, we will just leave the while loop. Otherwise, is not the case, then we will just basically say, okay, print invalid answer, and then we should just jump back here and then go again. I is always increased by 1, so basically if we do it 5 times, it will basically stop. Now if it stops because this condition was false, which means we have tried it more than 5 times, then we can have an else clause, and then this else clause will be executed. So we say print too many invalid trials, and then we will just say print assume answer is yes, and we will just set answer to the string yes. And then here we are just printing the answer, your answer was, and then we are just hitting printing answer. Okay, now let's try to execute that, whether it works, and then your answer is, let's say t, which is not valid. 3, 4, 5. We have tried it 5 times. Out of the 5th times it says too many trials, and assuming the answer is yes. So what is happening? I was always increased, and basically we were running this block here 5 times, and I was always increased, and at the 6th time when we here hit while, the while head at the 6th time, then I was not smaller or equal as 5 anymore. So the while loop was basically here, the while here inside was not executed anymore. But because we left the while loop due to the failing of this condition in the header, the else block has been executed. Now if we would leave the while loop via the break, then the else is not executed, and we can just try it, which I just started again, and I just say n, which is a valid answer, and you see your it only prints your answer was n, but the else block has not been executed because the while loop was basically left via break statements. So the else is always executed if the construct to which it belongs, the loop construct to which it belongs, was not left via a break statement. Okay, good. So that's very special to Python. I don't think there are many programming languages who are offering an else clause for a while loop. The while is, as we discussed, the while loop is very good if you know how often you have to execute a certain loop. If you do not know how often to execute a certain loop at the beginning, but there are cases where you exactly know how often to execute, and then you have this, or you exactly know over which values to iterate, which items to iterate, and then you would use the for loop. The for loop basically means a variable and an iterable object. An iterable object is something which has items over which we can loop. So basically that means the loop variable will get the values of this which are contained in this iterable object. What does it mean? If you remember, we had name1, that was a string, and now we can say a string contains items. Each character in the string is an item. So basically here I have something which has 4 items, the character J, the character O, the character H, and the character N. And then I can say, okay, for C, I will call it CC, the character in name1. And that would mean it will run over all the characters of name1, and in each loop, in each iteration, CC will get the subsequent values. So in the first iteration J, in the second iteration O, in the third iteration H, and in the fourth iteration N. And then here within the loop I can do with CC, which gets that the specific value, something. Here I will just print it. So I will just print the string character and value of CC. And if you execute it, you see that basically this thing has been executed exactly 4 times. So it was running 4 times over this block, and at each iteration the character CC had a different value. First the 0th item, the first, second, and third item of the string value. So this is basically how the for loop works. You can loop over something which contains items. Very often, however, what you want to run over is basically a range of numbers. So you know that you want to make a loop, let's say 100 times. And if you want to run over the range of numbers, then you should use the so-called range iterator. And the range iterator is creating basically a container which has the given number of characters, a given number of numbers. Sorry. So for example, if you just say range 10, let's say range 10. Then you get nothing really exciting, but if you want to show what are the items within this range, you have to apply the function list. We will treat it next time what it means. For the moment, just accept it that if you want to show the content of range, then you have to convert it to a list. And basically you say range 10 has basically numbers from 0, 1, 2, 3, 4, 5, 6, 7, 8. So basically exactly 10 items starting with 0. Sometimes you want to have a range which is not starting by 0 but other numbers. So you could have range, let's say 2 to 10. So then we are starting to 2 up to 10. You know, in Python, upper index is always excluded, lower index is always included. And if I want to show here explicit in this desktop, in this worksheet what it is, I convert it to a list. Otherwise, usually you never do that, only if you want to show the content. And then you see we were starting with 2. And then we were going up to 9. We have 8 items because the upper bound is always exclusive. I can also step sizes. So for example, if I could also go from 2 to 10 in steps of 2. And if you look at that, you see that I have 2 and the 3 is missing, then 4, 5 is missing, 6, 7 is missing, 8, 9 is missing, and 10 is not included anymore because 10 is the upper bound, and upper bounds are in Python always excluded. Okay, good. So this is what the range is good for. And again, for the for loop, similar to the while loop, you have exactly the same two constructs, break and continue. Break means that you can leave the for loop before the for loop terminates. Continue means you can jump back to the header of the for loop and then basically set for the variable which is here the next value. Okay, I mean a for loop, I mean you see it here, the for loop terminates because if the iteration over all the items has been finished. So for example, here we were iterating over those characters. When all characters had been consumed, then the iteration would stop. If you are iterating over a range, let's say for num in range, let's take this one, the last one, 2 to 10 in steps of 2, and we are just printing the number, then you are seeing you see that basically the iteration stops where all the items has been consumed. The items were 2, 4, 6, and 8, which is the range iterator provides, and once all the values has been consumed, the iteration stops. Now we can leave the iteration also earlier using the break. And here you have you see an example. Here in this example, we are looking for the first number which can be divided by 5. So let's say for range in for num in range, let's start from 3 and we are running up to 10. You know, upper index is not included, upper bound is not included, and now we want to check whether something is can be divided by 5. So we want to find the first number which can be divided by 5. How do we do that? Divided by 5, something can be divided by 5 if the remainder, this is the remainder of the division by 5, if the remainder is 0. We know if this here gives 0, then in Python this is interpreted as a logical false. So basically if I say if not num %5, which means if this is 0, then it's logical false. this is no, this logical false is inverted, so it's logical true. So basically, if this thing is divisible by 5, then we will just say break. We will just leave this loop, and then here we will just write print number, and we will just print num. And indeed, we were starting with 3, and then maybe I can just extend here. We are writing that we see which values checking, and then I'm just writing the current value, and then here result, and here we write the result. And then basically you see we were checking 3, we were checking 4, we were checking 5. When we were checking 3, the num percentage 5 gives 2, because the remainder is 3, sorry, it gives 3. The remainder, if you divide 3 by 5, it's 3. That's a logical true. If it's converted with not to a logical false, therefore the if is not executed. So we are going back, and the next number is coming, which is 4. The same thing happens, and then the next number is coming, which is 5. The division, the remainder, if you divide by 5, 5 by 5, the remainder is 0. That's a logical false, converted with a not to a logical true. Therefore, this thing is executed here. The if block is executed, and the if block is contains only a break statements, which means we are leaving basically the loop. So basically, similar to the while statement, you can, with a break, you can basically leave the loop. Similar, you can use also the continue statement if you want to skip back, jump back to the beginning of the loop. So if we wanted to get all the numbers, let's change it, and we wanted to get all the numbers apart of those which are divisible by, which can be divided by 5. Then I would just write here a continue statement. So basically, whenever we find something which can be divided by 5, we would just continue. And I will just do the get the print statement now here to the end, so that after the if statement, and then basically if we execute it, you see that we were starting with 3, 4, and the 5 is also, of course, we are also running over 5, but then basically here this this condition will be true, and then we will execute continue, and continue would just jump back, basically ignoring whatever is here, and num will get the next possible value, which is then 6. Okay, so you can jump back to the header of the construct, and then get the next, go into the next iteration. Also, the for loop can have an else construct if you want to need it, and it's very similar. The meaning is very similar to the while loop. It means the else is executed if basically the for construct was not left via a break statement. And we can use it in the original example as we had before. Let's here have the break statement in order to find the number. That was a result. In order to find basically the first number which can be divided by 5. And now let's assume that we are starting from 6, and then the result is 9, which is clearly wrong, because we were going over the loop 6, 7, 8, 9. None of them was divisible by 5, therefore this break has been never executed. But nevertheless, because the iteration is finished, we have consumed all the items which were specified in this range, we will continue here, and this is clearly not what we want to have. But if we have here an else, and say this way, then as you see, this doesn't do what it was intended to do. Why? Because so it doesn't do what it's intended to do. Why? Because when is this else block executed? This else block is executed if we were leaving the for statement not via a break, but we would leave it by break if we found something which can be divided by 5. So basically here we should write, okay, this means, this print means that no number divisible by 5 has been found. So this is basically exactly the one which should be executed if we were not successful. and then it says no number divisible by 5 had been found. On the other hand, if we start, let's say, from 3, then this will never execute it, because here, if we give the number of num, it's 5, because when num was set to 5, we were leaving the for construct by a break. So the else again is executed if you are leaving the for in the normal way, because all the items has been consumed, and not via a break. Okay, and you can use it as I said here. We have a snippet and the equivalent code. Then it's of course a little bit more compact to write it in this way, but you have to know what the else exactly means. Good. The last thing I would like to discuss in this session is string formatting, just to make sure that if we are giving out some output for the user, it looks nice, sort of ordered, formatted. And the string formatting can be done in Python by using the so-called SYN formatting mini language. And basically here you see it, that you can provide a string with some kind of placeholders, and to these placeholders you can you can provide some values. So let's have an example. Let's assume I have a string and I say A0 is equal, and then I'm putting in a placeholder. The placeholder is put in curly braces, and then I say A1 is equal another placeholder, the placeholder number 1. Here this is the placeholder number 0. And how do I provide values for this placeholder? I say format, and then let's say I will just pass num for the first for the 0 placeholder, and let's say num plus 1 for the next one. And if you execute that, you see you get a new string as a result. This is again, the result is a string. However, in this string, the first placeholder was replaced by the first argument of the attached format function. The second placeholder here was replaced, basically the value of the second argument which we passed to the format function. So this is basically it is. You can of course access to this access the same argument more than once. So if I wanted to say, okay, just a trivial operation, I would say placeholder 0 times 1 is equal placeholder 0, and then format and then pass a number. Now I pass the number explicitly, like 33, and I say enter, and then I am accessing here placeholder 0, and here I am accessing placeholder 0 again. So you can access a certain argument of the format statement, of course, more than once. Okay. We can of course do more than this, more formatting than this. We can also make options how to format a given entry. And just going back to the original example here, I could just say, okay, let's print it as an integer. So this colon D means print the placeholder 0, the value for placeholder 0 as an integer. And I can give you also the width, character width, which means, let's say I am saying 4, and here the same I'm doing 1 colon 4D, and let's see what happens. What happens is that I get the same thing as before. Here the placeholder has been replaced by the value of the zeroth argument, so the first argument, if you want to say it this way, of the format function. But what you see is that here the character width was set to 4. So basically I have A0 space equals space. This was in the original string, and then the integer which was passed here as the first argument of the format statement. So this is placeholder 0. Was written as an integer at a field width of 4, which means basically 1, 2, 3, 4. It consumes exactly 4 characters, and it's automatically, if you format this way, it will be automatically right bounded. So it will written on the right of the field width of the character field. The same here. The number has been printed and it was aligned to the right. I can do the same with floating point numbers. Let's say, or let's just edit this example again. So I will just now treat them as floats. Although they are integer, that works very good. And now it's written on, you would think that you get a float on a width of 4, but this is not what is happening. And the reason why it's not happening, because we should specify how many digits we should print. And this to specify with the dot and then the number of digits. So if you have a float, you can additionally to the field width with dot specify the number of digits, the number of decimal digits which should be printed. And now that looks much better. You see it has been 5.00. Here the field width is 1, 2, 3, 4 characters. Also the field width here is 4 characters, and we were using two digits. And you have seen already before, this is something I would like to make you aware of. If you specify a format which needs more character than you specify here as field width, then basically it will be automatically expanded. So even if you say we are using a field width of 2, if you say .3 and .3, so include 3 decimal digits, then it doesn't work, because the 3 decimal digits plus the dot plus the 5 together needs 5 characters, and this is expanded accordingly. Okay, so it's automatically expanded. This I also here mentioned here. Here you can have a look at all the styling options. I won't go through that. Just have a look at the those styling options, and especially in the format specification mini language. This is very, very powerful if you want to make complicated output. Many things can be covered. So basically the only thing which I wanted to tell you is that the field width is automatically adapted if the field width which you specify is too small, so it's nothing is cut or chopped off. The second thing is what happens if you want to specify a curly brace, because if you specify a curly brace, then basically it's interpreted as a placeholder. But let's assume you really want to have a curly brace. So basically you want to specify curly brace on them placeholder and curly brace. Then if you want to have a literal curly brace, you have to write it twice. And now if you have a look at that, I'm just passing the value 11, and what do I have? I have a literal curly brace because I have 2 curly braces. Then I have the placeholder, 0 placeholder, which is written with curly braces as a syntax, and then I have the literal curly brace again, and if you execute that, you see that you get curly brace 11 curly brace, right? And the last remark is that if you have a recent Python, which we definitely have, you can also leave away the numbers in these placeholders, provided you want to access. You have every provided every placeholder accesses the next entry in the format statement. So basically here, for example, I could just leave away. Okay, let's get rid of the formatting. I can just leave away first. I can just leave away the curly the placeholder. Why? Because the first placeholder will access the first argument of format. The second placeholder will access the second argument of format. And as you see, that works as well. Now, if you want to nevertheless specify a format, that's still possible. You can say, let's say 5D, so an integer with the field width of 5. And then again, you don't have to specify the placeholder number as long as each placeholder is accessing always the next argument of the format statement. Good. So with that, basically, we covered everything I wanted to tell you in this lecture. And then basically now what I would suggest you, basically what you should do is to go for the exercises on the website of the lecture. You find the exercises. Please try to make all of them. They are not very complicated, so none of them exercises needs more than 15 lines of code. Some of them even much less. So they are not complicated. It may be a little bit difficult for us if you're a beginner, but take your time. Try to make a very small working program, even if it doesn't have the full functionality which is required, and extend it always step by step. So do not try to write the entire exercise immediately, but make a small piece of code which works and then extend it line by line until it results in the desired, or it gives you the desired result. And make sure that you understand what you do and why it works and how it works. And if you do all the exercises, then I can guarantee you that you will have a very nice knowledge of the loop structures, of the if branches which we discussed today, and all the data types, or most of the data types which we discussed, and then you have the right basics to continue with the next lecture. Thanks a lot for your attention, and I'm looking forward to our next session. Take care. Bye.